So in 12.5, we're going to be looking at the properties of logarithms. And what drives me crazy when I was taught these was that I was just taught to kind of memorize these. But if you remember, logarithms are the inverse of exponents, right? So the whole purpose of this is like to undo that 2 to what power makes 5. And so if you already know the rules for exponents, and you should if you're in this class, that if we have two bases and we're multiplying, we can add the exponents. Then it would make sense that logarithms would have the inverse relationship. Here, multiplying, we add the exponents. Here, if I'm multiplying, right, then I can add the logarithms. It's literally an inverse relationship. Multiplying turns into adding. Here, multiplying turns into adding. It's kind of the same relationship. Same here. Look, b to the x over b to the y. Division turns into subtraction. Look over here. Division can turn into subtraction. It's the same relationship. The same rules that we have for exponents apply inversely. If I'm subtracting logarithms, I can turn them into one condensed logarithm with division. The power rule, if I have a base and power to a power, I can multiply them. Here, it gets a little crazier, but basically if I have an exponent, I can bring it forward and I can make it multiplication. Powers turn into multiplication. It's the same relationship, okay? So multiplying, adding, here if I'm multiplying inside a logarithm, we can add two separate logarithms, get the same result. Here, dividing, we can subtract the exponents. Here, if I'm dividing inside the logarithm, I can subtract. Two separate logarithms get the same result. And last, I can change a power, bring it forward, and turn it into multiplication. Okay, so those are kind of our new sets of rules, but they're not really anything new. They build on the rules from exponents already. Everything on the left side is condensed because it's a single log. It's kind of put together. Everything on the right side is expanded, multiple logs. So keep that in mind as we're continuing. We are going to expand log base 5 of 6 times 9. Well, we just over there said, well, it's the same kind of as the rules of exponents, so multiplying turns into what? We're going to expand this into 2 logs, 2 terms, 2 logs, both base 5. Of what? Well, what are the numbers? 6 and 9. And the multiplying turns into addition. These give us the same result. Log base 3 of 3x. This is multiplying, isn't it? Well, I can write that as log base 3 of the first term, 3, plus log base 3 of x. So you're going, okay, so why are we really doing this? Well, we actually can simplify something this time. Log base 3 of 3. If you can read a logarithm, 3 to what power makes 3? We can simplify that to 1 plus log base 3 of x. Log base 6 of 3 plus log base 6 of 12. Here's kind of the first time we're going to have something that actually has a purpose when I condense these. I can condense these two into a single log, same base, and the addition up here, right, multiplying turn into adding. Down here, condensing the adding of logarithms can turn into multiply. But I can actually multiply those. So log base 6 of 3 times 12, log base 6 of 36. And I can simplify that. Log base 6 of 36, 6 to what power is 36? Is 2. So, I mean, I can do that. I have a calculator, log base 6 of 3, log base 6 of 12. Let me see, I should have those right here. Log, of course, there we go. Wrong button. All right, do we see log there? Yes, log base 6 of 3 plus log base 6 of 12. And this should equal 2. And I like that because each of those individually, log base 6 of 3, oops, there's a decimal, is not very pretty. And the other one, log base 6 of 12, those are not pretty numbers, but they do add together to give us exactly 2. All right, we're going to expand this, right? Two ways of thinking about this, and this is probably the one that's bothering you the most, but I said we can take that exponent, that 3, and we can expand it. We can bring it to the front and make that 3, oh my goodness, try that again, 3 log base 4 of x. There's a quick way of kind of proving that this will work. Look, if I have log base 4 of x cubed, that's like log base 4 of x times x times x. And we're feeling okay turning multiplying into adding, aren't we? So this would become log base 4 of x. Multiplying turns into adding. Log base 4 of x. Multiplying turns into adding. Log base 4 of x. Well, here I have log base 4 of x plus log. These are 3 of the same thing. So they can add to give us 3 log base 4 of x. Now that's not how I'm going to solve it. I just think it's neat how those things relate. Log base 4 of 7/9. So you're like, oh man, a fraction, division. Okay, well let's expand it. We can rewrite this as log base 4 of the top number. Division turns into log base 4 of 9. Log base 7 of 14 minus log base 7 of 2. We can condense those. Two logarithms that are subtracting. This can be written as log base 7 of the 14 over the 2. I can expand division into subtraction. I can condense subtraction into division. This again simplifies to what? Log base 7 of 7, which is just 1. So log base 7 of 14, where was that? Log base 7 of 14. Oh, that's a pretty number. And we just said log base 7 of 2, another interesting number, but when I do, alright, where are we at? Okay, but when I subtract them, so log base 7 of 14 minus log base 7 of 2, I get 1. I think that's pretty snazzy. Okay, I know I haven't convinced you yet, but once again, we'll get there. What's log base 8 of 8 to the 5th? Well, I could sit there and multiply out 8 to the 5th, or what I can do is I can take that 5th power and bring it to the front. Exponents can turn into multiplying, so this becomes 5 times log base 8 of 8. And that log base 8 of 8 can be simplified. 8 to what power makes 8? This just becomes a 1, so I'm just left with 5 times 1, or 5. Now this one's tricky. Why would you ever put a fifth root, or a root at all, inside a logarithm? There's no rules for roots in logarithms. But we could rewrite that root, couldn't we? A couple chapters ago. Didn't we say the fifth root of x squared is the same thing as x to the 2/5? So what would that do for me? What would I want to do with that is I can now take that 2/5 to the front and say 2/5 log base 2 of x. And so that's actually, I think, a lot simpler than what we'd started with. A couple special properties. Log base b of b to the x, we said the x can come to the front. Log base b of b becomes 1, cancels out. Also, kind of the inverse of that, if I raise b to the log base b of x, these are inverses, so they also cancel out, leaving us with the x. Let's see. Log base 2 of x equals 3. I can deal with this one of two ways. I can just rewrite this as base to the exponent is equal to x and solve it. Or I actually can now solve this, since I'm thinking about what inverses mean, is I can actually solve this by doing the inverse of a log. We said b raised to the log base b cancels out. So if I have log base 2, I can undo that log base 2 by raising both sides as a power of 2. Now this is crazy. I think, when we first do what you do to one side, you do to the other, we're like, okay, I kind of get it. This to me is crazy. We are literally raising both sides of the equation as an exponent of base 2. You're like, why would we ever want to do that? Because 2 raised to the log base 2 would cancel. They are inverses, leaving us with just x is equal to 2 to the third. But that's the same stinking answer, isn't it? See, but when you did this, it was kind of a trick. You learned to read it and you just did it. On the left, this is how we justify it with the algebra. So either way, we get that x is equal to 8. You can solve it by kind of using the tricks, or you can solve it by understanding if the inverse of a exponent is a log, the inverse of a log is raising both sides as an exponent. A little more advanced, but just kind of get you prepped for that idea. All right, here's where things get interesting, okay? We are going to expand this, okay? So it's currently condensed. We're going to expand it. We're going to start with the product and quotient rule. We are going to save that exponent for the end. We cannot just bring that 5 to the front, because that would imply that everything there had a fifth power, and it doesn't. So what we do is we start by finding every term that's separated by multiplying and dividing. We got a 36, we got an m to the fifth, and we got an n. There are 3 terms. That 36m to the fifth is not one term because it's 36 times, and multiplication expands in logarithms. So since I have 3 terms, we will have 3 logs expanded. The multiplying, the 36 stays positive. I don't know why I wrote a 5 there. The m to the fifth, it's multiplying, is positive. And the n is dividing. Dividing expands to subtraction. Am I done? Well, I'm done with the product and the quotient. Multiplying stayed positive. Dividing became negative. Now the power rule says, well, that 5 can come to the front. So to get full credit, I need to bring that 5 to the front. I don't know why I keep writing a 35 for that. Minus log base 6 of n. And don't forget, you still have to not check out your brain. Log base 6 of 36, if you can read a logarithm, you know that that is 2, because 6 to the second power makes 36. So this is how I would write my final answer. That is expanded completely. Don't forget to simplify where you can. Log base 7 of this mess. I see 3 terms, a squared, a b, and a c. This will then expand into 3 separate logarithms. On the top, the a squared stays positive. On the bottom, the b becomes negative. On the bottom, the c becomes negative. Somebody just did not like what I just did there, because you're saying, you told me that multiplying turns into adding, and yet both of those became subtraction. Why? The short answer is this. Anything on the top is multiplying will be positive. Anything on the bottom is division, so become negative. If you don't like that, I can show you another way. This is really the same thing as log base 7 of a squared. Division is minus log base 7 of b plus log base 7 of c. See, that multiplying does become addition between those two, but because they're both on the bottom, this minus is going to distribute and make them both negative. Okay? So I think it's easier just to think anything on the numerator is multiplying is positive, anything in the denominator is dividing, so it becomes a negative logarithm. Anything else we can do? Yes, to expand the power. The 2 comes to the front, so we end up with 2 log base 7 of a minus log base 7 of b minus log base 7 of c. Here's one that is expanded. Can we condense it? See, when I went from condensing to expanding, we started with the product and quotient rule. Here we're going the opposite direction. So we will do the opposite order. So let's see. I've got to deal with the powers. You're like, I don't see any powers. Yeah, but any of these numbers multiplying in the front can be condensed, can be brought up first. I cannot bring these logarithms together with those exponents or with those numbers in front of them. So it becomes log base a of x squared plus log base a of y to the third minus log base a of z to the 1/2. By the way, why didn't I move the negative up with the exponent? I don't want to deal with a negative exponent. And second of all, the subtraction will be dealt with right here in the product quotient. So you can just bring the 1/2 up, leave the negative there. Now this is ready to condense. 3 logarithms condense into a single log base a. Everything adding, everything positive goes on the top, is multiplying. So x squared, y to the third. Everything that is subtracting. If there were lots of things subtracting, we'd have several things down here, but anything subtracting goes to the bottom. I would be totally fine with this answer. Leave it like that. They may write that as x squared y third and square root of z. They might do that. So you could do that in that place. I wouldn't really care. Okay? So, yeah, there's going to be some crazy things. One more thing, and I'll kind of once again go, why the heck are we doing all this? What is log base 3 or base 4 of 3x plus y? Please avoid the temptation on this. You're like, oh yeah, adding turns into multiplying. No, don't do it. See, when I did that at the very beginning, adding turned into multiplying when I had adding 2 separate logarithms turns into multiplication on the inside. I don't have any rule with adding inside a logarithm. So follow your rules very carefully. Make sure I don't go too far. All right. So follow your rules very carefully. This doesn't have any rule that applies to it, so it is already simplified. There is nothing we can do to this. Don't start making up new rules. Write those rules down and refer to them while you're going through the problems. Okay? So I'm going to do this one more time just to make sure we understand, why are we doing logarithms? 2 to what power is 5? Officially, we're going to be solving this in the next section, but I want to show you this real quick. See, I can take this and I can write this as a logarithm. You're like, gosh, why? Logarithms are so hard. I hope they're not that hard. They really aren't. I'm going to rewrite this as a logarithm. I can write it as log base 2 of 5 equals x, right? Well, that's cool. If I could just do log base 2 of 5 in my calculator, I'm done. And by the way, I can. So I could type that in, hit enter, and I'm done. But if you don't have log with a calculator with log of different bases, we got to come up with another option. We got to find some way of undoing this exponent. What is the inverse of x being an exponent? Well, the inverse of the exponent is a log. In fact, that was our last rule. When I looked at all the rules, remember the very bottom rule said I can undo an exponent if there's a log. That exponent can be brought to the front. I can undo that exponent. So when I look at this, I could bring that exponent to the front if there was only a log here. So guess what? Put one. Can I do that? I can do anything to an equation as long as what we do to one side, we do to the other. I can do that. You can bring a log into the equation. You're like, why would I want to do that? Because what does that do for our x now? Our x can now travel. Literally, we can undo that exponent and expand it into multiplication. And now I can solve for x, because x is no longer an exponent. X is being multiplied, and I can undo multiplying by dividing. And this I can do in my calculator. I can say log base 2 of 5 log base 2 of 5 or the other way we got the answer, if you just have a log button that doesn't have a base, we got it as log base 10. We were able to undo it, and we basically did, let's see, log, leave that alone, of 5 divided by log of 2. And you get the same answer. 2.32193. Is it right? Remember the original question said 2 to some power makes 5. And we're like, that's craziness. But look, we know that 2 squared is 4. 2 to the third is 8. So doesn't it make sense that somewhere between that second exponent and that third exponent, if we go from 4 to 8, there must be 5. So we can actually check this answer and say, does 2 to the 2.32193, does that equal 5? I got a calculator. 2 raised to the previous answer equals 5. I think that's awesome. We're going to keep building on this in the next section, so keep up the work.